All right, student notes, ellipses day 2. Today we're going to have a focus on writing equations in general form or standard form, and most of these equations will be written in standard form. So student notes, ellipses day 2. We are going to do a lot of practice in writing our equations in standard form. The majority of these problems will be written in general form, so we'll have to do some completing the square. Now, questions 1 and 2 are not that variety, so we'll look at how we're going to solve those instead. I'm going to begin by moving the 144 to the other side of the equation, and from there I will divide out 144 to get that familiar 1 value next to on the other side of the equation, equals 144. So remember, in standard form of the equation, this number must be 1, and the way to do that is by dividing both sides by 144. Once I've done that, now I have my value of 1 over here, which is how it is written in standard form, and then these two values cancel out to give me my a value and my b value underneath both the x and the y's. So it's x minus 2 squared over 4 plus y plus 3 squared over 36. This time the 300 is already written, so I will on the right side of the equation, so I'll simply divide it out to the other side. Again, that gives me that familiar 1 here, and then these values cancel each other out, giving me my a and my b both below the x and y values. The more familiar way of doing this, based on circles day 2, is going to be through completing the square method. So the thing you're going to notice, the difference you're going to notice between today's work and circles day 2 was that now you're going to have those values of the coefficients of both the x squared and the y squared term being something other than 1. So I'm going to regroup, and I get 3x squared minus 24x plus 4y squared minus 16y equals negative 52. So now what I'm going to do is, in grouping these values, I must pull out that value that is both on the x squared and the y squared term. Now remember, grouping is critical here because I do not need to pull out a 3 from all of these numbers. I only need to pull a 3 from the 3x squared and the 24x. The same holds true for the 4. So now I get 3x squared minus 8x, and here's where I'll just go ahead and skip the step of rewriting and go ahead and complete the square. Okay? Plus 4 times y squared minus 4y plus 4 over 2 squared. Remember, the negative sign gets absorbed by your square, so that's why I don't bother writing it, equals negative 52. Now here is where your understanding of completing the square must be correct. Remember, there's a weight of 3 on the 8 over 2. We must acknowledge that it is there. Remember, there's a weight of 4 on the 4 over 2, which we must also acknowledge that is there. So now what we get is 3x minus 4 squared plus 4y minus 2 squared equals 12. Dividing out 12 all the way across will finish the work of putting this in standard form. X minus 4 squared over 3, over 4, plus y minus 2 squared over 3 equals 1. The next step is finding all of the critical values of this ellipse. I prefer to draw the ellipse on a coordinate grid system, so I encourage you to do that before moving on. But since we spent all of yesterday's notes doing that, I'm going to go ahead and just fill in the critical values as they are. Make sure that you're working this independently so you are finding these same values and you're able to understand how I got these values, and more importantly, checking that I actually gave you the correct values, because you know me. Major axis. That's at 2, 2 and 6, 2. Minor axis. That's going to be at 4, 2 square roots of 3. Sorry, I got to add something in there. 4 minus 2, 4, 2 minus the square root of 3, and 4, 2 plus the square root of 3. Now, of course, I could give you the estimated answer there, but I'm not going to do that. I'm going to give you the exact answer. Remember, this is a single number. It's just that you can't combine a whole number and a radical together to make an exact answer, so that's why I've left it in that form. Okay? If it's more beneficial for you to leave it in an estimated answer, then please round to 3 decimal places instead. All right, the foci are located at 3, 2 and 5, 2. All right, question number 4. Again, we're going to rewrite using grouping. And I'm just going to go ahead and move that 9 automatically. Now I'm going to group. Notice this time I only have to pull out one value, and that'll be the value on the x squared term. Remember your weight where appropriate, because now you'll notice that there isn't going to be a weight on both of them, just on the x value. And I ran out of space, so I'm just going to write this underneath here, adding that in. So now I get 4x minus 1 squared plus y plus 3 squared equals 4. Divide out both sides by 4, and my equation in standard form is this. Okay. Now it's asking me to graph the ellipse and find its critical values. I do find that graphing the ellipse first will help me find the critical values a lot better. So I'll go ahead and do that. At 1, -3, I find my center. The value of A is going to be 2. The value of B is going to be 1. And my ellipse looks like this. Alright, now from here I can go ahead and find the rest of the critical values more easily. So of course my center is at 1, -3. The major axis endpoints are located at 1, -1. and at 1, negative 5. The minor axis endpoints are located at 0, negative 3, and 0, 2, negative 3. The foci are located by finding c squared equals a squared minus b squared. That's going to be 4 minus 1, so that means the value of c is going to be the square root of 3. So the foci are located at the value 1, negative 3, plus or minus the square root of 3. Now this is in relationship to what I wrote prior for the minor axis. I've even shortened it because you'll notice it's plus or minus in both of those values. Okay? If you are not interested in using this shorthand method, then please continue to write out both ordered pairs like we did in question number 3. Or if you are still uncomfortable with these estimated answers, then go ahead and round it out to 3 decimal places. Question number 5. Always graph. It makes it a lot easier to see what you're working with. All right, so the center's at 4, 5. Uh, 0, 5 here, and 8, 5 here, and one endpoint of the minor axis is at 4, 4, which is here. That means the value of b is 1, the value of a is 4, so now I can go ahead and write my equation. A equals 4, b equals 1, c center is at 4, 5. So it's going to be x minus 4 squared, and notice that a is going horizontally, that's why I'll be putting 16 underneath the x. Y minus 5 squared over 1 squared, which is that, and it's all equal to 1. Alright, again, graphing is very useful here, so I encourage you to graph. So at 1, 1, and at negative 5, 1, so that means this is the length of the major axis. And then we'll go ahead and do negative 2, negative 1 here. So that means that the center of this ellipse is located right there. And so the center is going to be negative 2, 1. The center of this ellipse is located right there. Thank you very much. That's it. At 2, 1. The length of the major axis A is going to be 1, 2, 3. The length of B on the minor axis is 2. And the equation is going to be x plus 2 squared over, notice the major axis is horizontal, that's why the 9 will go below there, plus y minus 1 squared over 4 equals 1. Question number 7 and question number 8. Alright, it's slightly larger numbers, but that is not a big deal. They will hopefully all work out for us. Minus 32x plus 25y squared minus 100y equals 284. Go ahead and group, pull out your values. So that's going to be 16x squared minus 2x, not so bad, plus 2 over 2 squared, plus 25 times y squared minus 4, y, also not so bad, plus 4 over 2 squared. Okay, remember you're going to add that weight as well as the numbers you just used to complete the square. So the first weight is 16, and now it's going to be times 2 over 2 squared. That second weight is 25 times 4 over 2 squared. Alright, that gives us 16 times x minus 1 squared plus 25 times y minus 2 squared equals 400. Dividing out your 400 to both sides. And now we get x minus 1 squared plus y minus 2 squared equals 1, and these respectively are divided over 25 and 16. Alright, center is located at 1, 2. Major axis endpoints are located at negative 4, 2 and 6, 2. Minor axis endpoints are located at 1, negative 2 and 1, 6. And the foci are located at negative 2, 2 and 4, 2. Please use graphing to help you if you have difficulty determining each of those locations. Finally, number 8. Alright, we're given some critical values and expected to find the equation of the ellipse. So if the endpoints of the minor axis are negative 6 and 7, here, and negative 6 and 3 here, that's the value of 2b. Okay? The length of the minor axis is 2b units long. Then we're going to find the major axis endpoints to be located at negative 3, 5 here, and negative 9, 5 here. This means this is the length of the major axis, 2a. And the intersection of those 2 points is the center of my ellipse. In this case, that's negative 6, 5, which, if you are observant, you'll notice is the intersection of both the x and the y values there. The length of A is 3, the length of B is 2, so A equals 3, B equals 2, x plus 6 squared. Because A is horizontal, we will put the 9 underneath it, plus y minus 5 squared over 4 equals 1.